In this video here, we're going to be talking about how to solve logarithmic equations. Now, I just did another video where I talked about how to solve simple logarithmic equations where I get a log on both sides and they have the same base, so I just kind of set the stuff inside the logs equal to each other. This is the process that we'll use when we don't have those simple types. This process will help us solve any logarithmic equation, right? So even those simple ones, if you don't recognize that it's one of the simple ones or if you forget what to do, if you follow these steps, you'll still solve those simple equations as well. It's just this will take a little bit more work than what I showed you on that other video, right? But 3 steps, and if you watch the video that I did on solving exponential equations, the 3 steps to solving logarithmic equations are fairly similar to the 3 steps we talked about for solving exponential equations, which makes sense because exponentials and logarithms are inverses of each other. So all of the things that we do with exponential and logarithmic functions and equations are related in some way, right? So the 3 steps here, pretty similar to the 3 steps for solving an exponential equation. All right, so step number 1, isolate the logarithmic term, right? The log, base, whatever's in parentheses, we want to get that by itself on one side of the equation. Now, sometimes we might have to combine logarithms together. Like if I have 2 logs being added or subtracted, I have to use the laws of logarithms to combine those into a single logarithm in order to get it isolated. Right? It can't be isolated if there's more than one. Isolated, like the definition of that means just one by itself. Right? So if I have more than one log, I use the laws of logarithms to combine them and get that one by itself on one side of the equation before I proceed to step 2. All right, step number 2, the key step to solving a logarithmic equation. Remember, exponentials and logarithms are inverses of each other. So if I have to solve if I have to solve a logarithmic equation, I switch it into exponential form. Right? I do the inverse thing. Just like when I'm solving exponential equations, I use logarithms because they're inverses of each other. Well, if I'm solving a logarithmic equation, I use the exponential form. Right? So I use a little process to switch from logarithmic form to exponential form, which is something that I covered in another one of my videos, like how those 2 forms are related and how you can switch from one to the other. So if you didn't see that, you might want to check that out because, like I said, it's the key step to solving a logarithmic equation is switching it into the exponential form, into its opposite or its inverse. And once we switch it into exponential form, then we will be able to solve for the variable, and at that point, it's just doing whatever algebraic stuff you need to do to solve the equation. Sometimes it's just a basic linear equation. You just move stuff around to solve for x. Sometimes you might end up with a quadratic equation where you have to use factoring or the quadratic formula. Just whatever it is you end up with after you switch to exponential form, you use algebra to solve that equation that you're left with. Right? At that point, though, when you switch to exponential form, the logarithm should be gone, and you can just do basic algebra to solve the equation. All right, so those are our basic steps for solving a logarithmic equation. Like I said, similar to the steps if you saw the video about solving exponential equations, it's a really similar process. Remember, for any type of equation, we're always doing the inverse in order to solve it, right? If I have x plus 5 equals 3, well, the inverse of plus 5 is minus 5, so I just subtract 5 to the other side of the equation. Well, for logarithmic functions, the inverse is exponential, so I have to change my logarithmic form into the exponential form in order to solve it. All right, I'm going to pause the recording here and erase these 3 steps and then put up an example or maybe 2. I don't know if they'll both fit at the same time, but we'll do a couple examples here of actually using these steps to solve a logarithmic equation. All right, I decided to just put one up at a time here. So the first one, ln of x equals 8, and we want to solve that equation for x. Right, so just like I talked about when I did the videos talking about solving exponential equations, first thing you want to do is identify what type of equation you have so that you know which methods to use to solve the equation. Right? If you have a linear equation, you do one thing to solve the equation. If you have a quadratic, you do something totally different. If you have an exponential equation, you have even different methods, and logarithmic equations is also something different. Right? So the different types of equations that you see, there are different methods that you need to use to solve them. Identifying logarithmic equations is pretty simple because there's either an ln or a log written in the equation. It's hard to miss, right? So when I see ln of x equals 8, it's pretty obvious that that's going to be a logarithmic equation. Because remember, ln stands for the natural logarithm. That's the logarithm that has base e, right? That special number e that comes up so much when we're dealing with logarithms and exponential functions. All right, so that's what we have here. All right, so step number 1 of solving a logarithmic equation is isolate the logarithmic term on one side of the equation. Well, I already have that here, right? ln of x equals 8. The log and its argument of x, ln of x, is all by itself, right? When we say isolate the logarithmic term, it doesn't mean just the ln, right? You can never have a log or an ln just by itself without something coming after it. And if it helps, you might want to write your logs with like ln or log of something in parentheses. You can't have the ln without the something in parentheses, right? There's no such thing. Like if you just have, ln equals 8, that doesn't make any sense mathematically speaking, right? You can't have an ln without something in that function, right? So when we say isolate the logarithmic term, it means the log or the ln and then whatever comes after it, right? What we call the argument of the logarithmic function. That's all by itself on one side of the equation. So step number 1 is already done for us in this problem. Just the way it was given to us, step number 1 is already completed. All right, so step number 2 then is to switch our logarithmic equation into exponential form. Right, and again, I did a video on this where we talked about how exponential and logarithmic equations are related to each other and the process you can use to switch from one form to the other. So you might want to review that video before you watch the rest of this. But just if you recall the way we do that, natural log, so the base of the natural log, remember, is the number e. Right, so if I want to change this to exponential form, I do e raised to the power on the other side of the equal sign. So e to the 8th power equals whatever's in here, which is x, right? So that's how we switch from a logarithmic equation into an exponential equation. Whatever the base of the log is, the exponent of that base is on the other side of the equal sign, so it's the base e to the 8th power equals whatever's in these parentheses of the logarithm, which in this case is just the x. And then step number 3, like we talked about a few minutes ago, is to then solve the equation for x. Well, in this case, we already know what x is equal to. X equals e to the 8th power. So this is about as easy as a logarithmic equation can get. All I have to do, like it's already isolated, I just switch it to exponential form, and then I already have the x by itself. So x is equal to e to the 8th power. Right? So that's what we call the exact solution of this equation. Right? Just like when we solve the exponential equations, we have exact solutions and then we have approximate solutions. Right? So if I want to get the approximate solution, I can put this into the calculator. Right? I just type in e to the 8th power, and it gives me a decimal approximation of that value, which is 2,980. Right? So x is approximately equal to 2,980.957987. So let's call it 0.958. All right, that's our approximate solution to this equation. Right? Remember, when we did exponential equations, we said most of the time the answers come out to irrational numbers, like crazy decimals. So a lot of the times, when you try to give a decimal answer for it, you're giving an approximate answer, right? With logarithmic equations, that also is true, although with logarithmic equations, more often than with exponentials, you can get nice numbers for your answer. So you might solve a logarithmic equation and get like x equals 2 or x equals 5 or something like that. So that is possible. It happens more often than with exponential equations. But still, a lot of the time we get these weird irrational numbers. And so to give the exact answer, x equals e to the 8th power. Approximate answer is this down here. So for the problems you're doing, read the instructions. If it says give the exact answer, you want to give it as e to the 8th power. If it says give an approximate answer, it'll probably tell you how many decimal places to round to. So just make sure you put this answer in your calculator and then just round to however many decimal places they tell you. All right, so that's our first example of solving a logarithmic equation. I'm going to pause the recording again and erase this example and put up one more that we'll talk about and solve another logarithmic equation here. All right, for this next example, our equation is log base 2 of 25 minus x equals 3. All right, so once again, logarithmic equation, easy to identify. I mean, the word log is right there, so it's hard to miss that this is a logarithmic equation. All right, so we identify as a logarithmic equation. Step number 1, isolate the logarithmic term, which in this case, just like in that last example, the logarithmic term is already isolated. All right, we have the log with a base of 2 of this 25 minus x. Right, so again, when we say isolate the logarithmic term, it means the log and then whatever's in the parentheses with it, that's the logarithmic term. This entire thing is the logarithmic term, and we can't move any piece of that to the other side. Right, so like this 25 minus x here, I cannot subtract that 25 to the other side because the 25 is inside the logarithmic function with the x. Right, so since it's inside those parentheses, I cannot touch that stuff until I get rid of the logarithm. Right, same with the base of 2. Right, the 2 down here, I can't like divide that 2 to the other side or subtract it or anything. It's a logarithm of base 2. That 2 goes with the log. I can't just move it to the other side of the equation, so I have a log here without that 2. right? Those kind of things are not legal to do when you are trying to solve a logarithmic equation. Right, so when we say isolate the logarithmic term, that would mean if it was like 5 plus log base 2 of 25 minus x, well, that 5 out here, I would have to subtract that 5 to the other side to get that log by itself, right? Or if it was like 7 times log base 2, I would divide that 7 to the other side to get the log by itself, right? But the log and the parentheses, those stay together, and I don't put either one to the other side of the equation. Right. Also, another mistake I sometimes see people make, which is totally just off the wall and not even close to how you're supposed to do this, is say, well, log base 2, I need to solve for x, so let me divide this log base 2 to the other side. Right. Remember what I said a few minutes ago? You can't have a log without something in parentheses. Right. So I can't just say, well, let me divide log base 2 and have this be 3 over log base 2. That, mathematically speaking, that makes no sense at all. Right. So you can't do stuff like that. In order to solve a logarithmic equation, you have to switch it into exponential form. That is the way to solve a logarithmic equation. Right, so since my logarithm here is isolated like we just talked about, I go to step number 2, which is switching to exponential form. My base is 2, it gets raised to the third power, and then that's going to equal 25 minus x. Right? Again, that little circular pattern, the base to the power equals this in parentheses. That's how you switch from log form to exponential form. Really important to know how to do that, because to solve any logarithmic equation, that's what you got to do. Like every time you're solving a logarithmic equation, at some point, you switch it to exponential form. So you got to know that pattern of how to switch from one form to the other. All right, so we switch it to exponential form, and now we do whatever algebra is necessary to solve for x. Right, notice now that 25 minus x is no longer in those parentheses trapped inside the logarithmic function. That 25 minus x is just over there on the other side of the equation. So now I can do the things to solve for x, which in this case is going to be like subtracting that 25, dividing by the -1 that's in front of the x. Right, those are the things I'm going to have to do in order to solve this equation. Before I do that, though, when I switch this to exponential form, I get 2 to the third power. Right, well, I can evaluate 2 to the third power, right? 2 times 2 is 4, 4 times 2 again is 8, 2 to the third power equals 8. So when you switch to exponential form, if you are able to figure out what that's equal to, right? 2 to the third power is 8, so let's write that as 8 instead of 2 to the third power, right? And now I get 8 equals 25 minus x, and once again, identify what type of function you have, right? This is a pretty basic linear function, right? It's just an x to the first power, right? That's the kind of equation we have. And so now we just solve for x. Right? So now it's just subtracting 25, so 8 minus 25 would be -17 equals -x. I still have a negative in front of the x, so I have to divide both sides by -1, and I get x equals 17. Right? And like I said a few minutes ago, for logarithmic equations, fairly often you get nice numbers. You get like rational numbers or integers as your answers. You don't always get irrational numbers when you're solving logarithmic equations. In this case, we get x equals 17. So there you go. All right, so that is the steps of solving a logarithmic equation. Now, when you switch to exponential form, I think I mentioned this earlier, but I'm not sure, so just in case I didn't. Right, sometimes this will work out to be a quadratic. Right, this might have been 25 minus x squared here. Well, if it's an x squared, now I have to solve the quadratic equation. So now I got to factor it or use a quadratic formula. So again, as you're solving the log equation, it's always going to switch or morph into another type of equation. In this case, it transformed into a linear equation. So you have to still be aware of what type of equation do I have now? Is it linear? Is it quadratic? What do I have to do in order to solve it? Right. So you really got to pay attention to what you're doing and the intermediate steps, like what you end up with, because that's going to determine how you finish off the problem. Right, the process we had before, step number 3 said solve the equation for the variable, or solve for the variable. Well, that can take a number of different forms depending on what this equation looks like on this step. Right, like I said, this one was basic linear. Sometimes you got to factor it or use a quadratic formula if you have an x squared there. All right, so just pay attention to that stuff. And then just like with any other equation, if I take my answer, x equals 17, and plug it back into my solution, or back into my original equation, I would have log base 2 of 25 minus 17, and I would have to check to see that equals 3, which if you put that in your calculator, if you use the change of base formula, that log base 2 of 8, you'll see that does equal 3, and it checks out. All right, so With logarithmic equations, it is always a good idea to check your answers to make sure that they work. I just wanted to point that out to you before we finish here. All right, I'm going to make another video where I do even more examples, so check that one out.